All right, it says we're recording. Okay, so we're going to start on the new material here. All right. Okay, so 2.3, we're going to do trig functions of any angle. Okay, so basically what we've done up to in 2.2 is so as we're looking at our axis, this is quadrant 1, this is going to be quadrant 2, this is going to be quadrant 3, this is going to be quadrant 4. So we label these counterclockwise. Okay, so up to now, if we have, so the nice thing is we can put a unit circle here, and we can also draw our right triangle here. So if we have a point, maybe I should make this a little bit bigger. Okay, so if we have a point xy, okay, so then the length of this is x, and the height is y, and so we can use that to our advantage. And so in this case, if the sine of theta is so if this is your theta here, it's going to be your opposite over your hypotenuse, where r is the radius of the circle. Okay, so sine is y over r, cosine is going to be your adjacent side, so x over r, and then your tangent of theta is going to be y over x. Okay, y over x. Okay, so now the nice thing is, when we look at this, so we'll refer to the x-axis as the initial side, and then this other side here of the angle is the terminal side. So now let's talk about different angles. So when theta equals 120 degrees, okay, so if we're measuring it from the x-axis, if this is 120 degrees, then this angle A is basically a 60-degree angle because those are supplementary angles. Okay, so 180 minus 120 is 60 degrees. And so the nice thing about that is you can still, this is still xy, except for x is going to be negative and y is going to be positive in this case. If your angle theta is 300 degrees, so if you go all the way around to here, now you're in sector 4, okay? Then once again, if you take 360 minus 300, you've got a 60-degree angle formed. I guess we would measure this as a negative 60-degree angle. So positive 300-degree angle is the same as a negative 60-degree angle. And if we start doing coterminal angles, if we did a 520-degree angle, so basically we're going all the way around, so that's going to be 360 plus another, whatever that works out to be, whatever. So 540 minus 520, that's going to be just a 20-degree angle, your angle A there. So does that make sense? All right, so now the idea here is, let's find the 6 functions of the point where we're using x is -3 and y is -2. So I guess we can see here pretty easily if we use, I'm trying to hide the answers here, but so our radius is going to just be Pythagorean Theorem, 3 squared plus 2 squared. So your radius here, in this case, at this point, -3, -2, is the square root of 13. Okay. So let's figure out the sine of theta here. Okay. So well, maybe we'll cheat a little bit. The easiest thing to do is just to remember. Okay, so your sine of theta, so is going to be your let's see, sine is opposite over the hypotenuse. So the distance here is going to be -2. So x is negative, or excuse me, your y, it's in the y direction. So it's the y direction. So this distance here is -2 over your hypotenuse, which we know is square root of 13. So now, so that's basically just going to be your y coordinate over the hypotenuse. Your cosine is going to be basically just the x coordinate over the square root of 13. Okay, so so that's going to be the x coordinate -3 over the square root of 13. Now I probably should rationalize the denominator, but I'm not going to worry about that for now. Your tangent is going to be y over x, so it's just going to be -2 over -3, which works out to be positive 2/3. Your cosecant is just going to be the reciprocal of your sine, square root of 13 over -2. Your secant is going to be the reciprocal of your cosine, square root of 13 over -3, and your cotangent is just going to be the reciprocal of that. So that's going to be 3/2. So does that make sense for everybody so far? Okay. So yeah, it's really nice because now we can just use our coordinates to find these. So you'll notice here in both our sine and our cosine are negative because we're in quadrant 3. Okay, and our tangent is, well, no, our tangent's positive, but all right. So what if the point is on the x-axis? Okay, so the sine of 0 degrees is going to be 0 over your radius. And it doesn't really matter what your radius is at this point because it's still going to, 0 divided by anything is still going to be 0. Your cosine is just going to be your x coordinate over itself because x is your radius. Okay, so x over x is going to be 1. Your tangent is going to be y over x, and if y is 0 because you're on the axis, 0 divided by x is still 0. Okay, so let me ask you guys this question. Let's pick on whose turn is it? Let's pick on Jackson. We'll start in the middle of the room here today. So what's the cosecant of 0 degrees?
That's r divided by 0, so undefined.
Undefined. Okay, good job. How about let's see, that was Jackson. Josue, can you tell me what the secant of 0 degrees would be?
X is so sorry, I just get a little bit lost with this. I didn't understand.
Okay, so this is part of your table. Remember, what is the secant? How does the secant relate to the cosine?
Is it opposite?
What do you mean by opposite?
The secant is the opposite of the cosine, cosecant.
Okay, so opposite isn't the word I would use, but I think you're on the right track. But so
yeah, it's the
there's a relationship. Opposite is not what I would use, but yeah, what's so?
I don't know. It's I don't know how to say that word, to be honest.
Okay, what's the answer? Maybe if you just tell me the answer.
Well, just flip the bottom on the top and the top on the bottom.
There you go. That's called the reciprocal.
Reciprocal. Okay.
Okay, so what's the reciprocal of 1?
It's going to be 1.
1.
Right?
Perfect. 1 over 1 is still 1. Okay. Well done. Okay, so now after we did Josue, it must be Cameron Ravert's turn with the K. Cameron with the K. What is the cotangent of 0 degrees?
Okay, so the reciprocal of 0 over x would be x over 0, so it'd just be undefined, right?
That would also be undefined. Well done. Okay. So this isn't too bad, huh? I have a feeling we're going to get done with today's lecture early. All right, so now the question is, well, before I do the question, okay, so the question is, how do you know whether things are positive or negative, okay? And so if we've got a nice thing here. So all signs are positive in quadrant 1. The sine and the cosecant, and people usually just remember the sine because the cosecant is just the reciprocal. The sine is positive. So the sine is always positive in quadrants 1 and 2, okay? The tangent and cotangent is always positive in quadrant 3, and the cosine and the secant are always positive here. So the question is, how do you remember this, okay? So if you take the first word here, all sine, tangent, cosine, okay? So this will tell you which is positive. So here's how you remember. So if I use ASTC, now how do you remember what that is? So all students take calculus, okay? So that's how you remember that. Okay, so that's kind of your little thing to remember. So A for all, everything's going to be positive in quadrant 1. Sine is going to be positive in quadrant 2. Tangent's going to be positive in quadrant 3. And cosine is going to be positive in quadrant 4. Okay, does that make sense? Okay, so an example is given the tangent is negative 7/5, find the sine, and the sine is less than 0, okay? Find the cosine and the cosecant, okay? So let's talk about that. Okay, so we know, so as we're looking at our chart here, okay, so we know that the tangent is negative 7/5, okay? And we know that the sine is, the sine is less than 0, okay? So because remember, we know that okay, so the question is, which quadrant are we in? Okay, so as we're looking at this, if the sine is less than 0, we can't be in quadrant 1 or 2. Okay, so we have to be in quadrant 3 or 4. And we know that the tangent is negative, so we can't be in quadrant 3, so we have to be in quadrant 4. Does that make sense? Okay. So given this information here, okay, so we have to be in quadrant 4. Okay. So we've got to be in this quadrant. Okay. So in this case, remember the tangent is y over x. Okay. So in this case, our x has to be positive. So x is positive and y is negative. Does that make sense? Okay. All right, so we're in quadrant 4. So in this case, then we would know that y equals positive 7 and x is going to equal negative 5. Okay, so yeah, we need to make sure we don't get that mixed up. Okay, so that gives us our coordinates. Okay, So if y is positive 7 and x is negative 5, okay, let's figure out what would be the sine of theta. Okay, so let's figure out, so we know, so essentially we know our coordinates, and if I write this in ordered pair form, it's going to be negative 5, 7.
Wouldn't that put you in quadrant 2, though? With negative 5, positive 7?
Oh, you're right. Let me think about this.
Shouldn't it be positive 5 and negative 7 if we're going to be in quadrant 4?
You're right. Positive 5 and negative 7. Thank you. Also, I guess we can follow the signs there. In this case, yeah, because we're in quadrant 4. Yes, you're exactly right. Thank you. Don't let me lead you astray. Okay. All right. So sine of theta is positive 5, negative 7. Perfect. Okay. So let's go with Kobe Escalante. Can you tell me, so given this is your coordinates here, can you tell me what the sine is?
Let's see.
So do you have it memorized? We showed that on the last page, but it's been forgotten.
I'm not sure exactly what you are.
Okay, so remember back on the last page here, we said the sine was y over r. So that's what I'm looking at. Okay, so if your sine is y over r, now can we use this to, oh, I guess we need to figure out what r is first, right? What's r?
Square root of 74.
Oh, see, thank you, but we were trying to get Kobe to answer that one for us. Except for the question is, how did, and tell me your name again. How did Corey figure out that this is the square root of 74? Do you know, Kobe?
I do not know.
Oh. Okay, so Cliff, or Corey, it's Corey Clifford. I'm going to call you Cliff, I know. I bet you get called Cliff all the time.
Oh, I do.
Yeah. So Corey, how did you get square root of 74?
So we can just use Pythagorean Theorem and do...
Pythagorean Theorem. Okay, that's good. Stop. That's your hint.
There you go.
Pythagorean Theorem. So Colby, can you use the Pythagorean Theorem to figure out what r is? And by the way, Kobe, are you a big Kobe Bryant fan?
Yeah, I love him.
It's too bad. He died earlier this year. Okay, so how do you use the Pythagorean Theorem on this?
Would you just do each side and then kind of add it together, I guess?
Right, so it's going to be the square root of.
I'm not really sure how to solve this, honestly.
Okay, so here, let me
sure how to...
Maybe if I draw a picture, this will help. And I like this because, you know, you're probably not the only one that's confused by this. So some people get it. Okay, so we decided, okay, so this is my x and my y axis. We've decided previously, based on the information we've got here, tangent is negative 7/5. We've decided we're in quadrant 4. Do you understand how we got that point?
Sort of, yes, I do, but
Okay.
I'm also... we're kind of going along the unit circle, right? It's not anything besides that. Is that true?
The unit circle is related. It's yeah, pretty similar. So essentially, here's what we've got. So basically what we said is, okay, we've got a tangent is -7/5. Okay. We know that the tangent, as based on this previously, the tangent is, let me back here, is y/x, right? Okay, so the tangent is y/x. We know that the tangent of theta equals y, the y coordinate divided by the x coordinate, which in this case equals, so the value we're going to use is 5, comma, -7. Okay. So we know that the x value is 5, and we know that the y value is -7. Okay. So essentially what we're saying here, if I turn this into a triangle, a right triangle here, okay, what we're saying here is this is, the x-axis is 5 units and the y-axis is 7 units, or I could put -7 units because just to match my ordered pair. Okay, so now so this is going to be your radius r, if we call this a circle. Okay, so we need to figure out how long r is, and so r is the hypotenuse.
That comes out to, I think, 8.6.
Okay, and how did you get that?
I just, yeah, like it's the Pythagorean Theorem.
So it's the square root of what?
74.
Yeah, but so it's the 5 squared, right? 5 squared plus the -7 squared, which equals the square root of 74. Okay. All right, is that so? Yeah, so this is going to be the square root of 74, square root of 74. And I'm not going to worry about rationalize the denominator for this because I'm not going to worry about it. But okay, so as we go back to here, so okay, so this is 5 squared plus -7 squared equals the square root of 74. Okay, so we know what our r is. Okay, so now, okay, so using this coordinate right here, what would be the sine of this? So if this is my angle here, what's the sine if we call that a?
Would it be -7 over the square root of 74?
Exactly. Okay. Except for the way you said that, it was like you were asking me a question. You're supposed to say, not is it, you're going to say, it is. This is not Jeopardy.
Yeah.
It is.
Okay.
It is -7 over the square root of 74. Okay?
Okay.
All right. So is that good?
Yes.
So are you good enough that you can do the cosine of theta as well?
Cosine, let's see. Adjacent over hypotenuse.
Right.
That is that, what's that? R, according to these, what's it called? Formulas, is that, what would that be, x over r, or?
It would be very good. Okay. So you're going to tell, so, and I probably didn't emphasize that like I should have at the beginning of class. You want to memorize those 3 formulas. Okay. All right. So well done. Okay. So where am I going back here? Okay. So memorize those. You're going to definitely want to memorize those. Okay. So cosine of theta is x over r. And in this case, that's going to be
5 over the square root of 74.
Perfect. And for the trifecta, let's do the tangent of theta. We already got the tangent. I gave you the tangent. Let's do the cotangent. Well, here, a tangent. You better know the tangent of theta.
That's just the same one we have there, right? Negative
Yeah,
7.
it's the same one we have there, -7/5. Okay. It's also y over x. Y divided by x. 7 over -5. Or -7 over +5. All right, got to get my signs right. Okay. All right. So now, we've done enough picking on Kobe. Let's do the cosecant of theta. So the next person we're going to pick on is Nicole. Can you give me the cosecant of theta?
So would that be the square root of 74 over -7?
Okay, so I'll be asking the questions here. You're going to give me the answers.
I mean, it is.
Okay.
What is?
All right. The secant of theta is?
Square root of 74 over 5.
See, that sounded much more confident. That's good. And your cotangent of theta?
5 over -7.
5 divided by -7. Okay. So this is easy, huh? Okay. So really, what this comes down to, okay, so I'm glad we went through all that. Okay, maybe I'll leave that there. So the terminal side of angle theta must, so this is just going to repeat what we said. Terminal side of angle theta must lie in quadrant 4 because it is the only quadrant in which the sine and the tangent are both negative. We know that y must be negative and x must be positive, thus y is -7, x is 5, r is the square root of 74, Pythagorean Theorem, and so we figured all that out. Okay, so the reference angle. So given the angle in its standard position, angle theta, theta prime is the acute angle formed by the terminal side and the x-axis, okay? So this leads us to the reference angle theorem. So to evaluate the sine of theta, first determine theta prime. Then use either the sine of theta prime or its opposite as the answer, depending on which has the correct sign. Okay, so this is also this table here. All students take calculus. Okay, that's how you remember that. ASTC. Okay, so this is going to help you determine basically these sort of things. So your next quiz is going to be like, given something like this, tell me everything you can. And so you'll be able to have to figure out which quadrant it is, okay? Okay, so determine the exact value of each function. So here, I know you can hopefully not going to remember that. So let's go over here, okay? Maybe I'll make a new page here. Except for I don't want to. I'm just going to use different colors. Okay, so I've got the sine of 210 degrees. Find everything else, okay? Okay, so 210 degrees, the first question is, here, and I'm going to try to make sure that we've got, so remember this is quadrant 1, this is quadrant 2. Usually we use Roman numerals, but I'm not going to because it's hard enough to do regular numbers here. Okay, quadrant 4, okay? So remember, it's always 1, 2, 3, 4. It's always in counterclockwise fashion. So we've just picked on Nicole. So Samantha, it's your turn. First of all, where does the sine of 210 degrees, which quadrant is it in?
Quadrant 2.
Quadrant 2? Are you sure?
95%.
95%. I don't think
I'm trying to not word it as a question. So.
Okay, so remember here, let me ask you this. If I were to draw a very bad looking freehand thing, how many degrees is that angle there?
180.
180, and this is
Oh, so
210.
3rd degree. I mean,
Yes.
the quadrant 3.
It's in quadrant 3. Okay.
Okay.
So it's quadrant 3, and you already answered the next question. So this is going to be a 30-degree angle here, right?
Yes.
Okay. So this is 30-degree angle. Okay. So we're now in quadrant 3. Okay. So so the first question is, do you remember, based on that table that you've already memorized and you will have memorized for the test, what is the sine of 30 degrees?
1/2.
It's 1/2. Very good. Okay. All right. So now the question is, so we know that the sine of 30 degrees is 1/2. So we know that this value is going to either be positive or negative 1/2. So the question is it positive or is it negative? Okay, and I'm going to give you a little hint here. All students take calculus. Okay, so we know that the sine of 30 is 1/2. We know that this is going to be either positive or negative 1/2. Is the sine of 210 positive 1/2 or negative 1/2?
Negative?
Oh, that sounded like a question.
It is negative.
Why is it negative?
Well, I don't know if that's the same reasoning that you have, but since it's in the 3rd quadrant going down, all the units can be negative. Is that one way I can look at it?
Okay,
no?
so you're on the right track. You didn't quite say it correctly. So
Okay.
remember, in quadrant 1 and 2, so student, that really stands for sine, okay? So sine is positive in quadrants 1 and 2. It's going to be negative in quadrants 3 and 4.
Oh, okay. So just the acronym is just the other.
Yeah, so student, so think of student
distance.
equals sine, okay?
Yeah.
So everything's positive, so all are positive in 1.
Yeah.
Sine is positive in 2. What's okay? So we've done that. Okay,
Yeah, I
so
get
sine,
that.
so it's going to be negative 110. Okay, so now the question is, let's figure out the cosine, and we'll let Samantha off the hook. The cosine of 210. Okay. So whose turn is it now? Tayton, it's your turn. Tayton, can you tell me the cosine of 210 degrees? And before, well, maybe I should give you a break. Here. I'm going to move this over here. First of all, can you tell me the cosine of 30 degrees? That's our reference angle. Have that memorized yet, Tayton?
Sorry, my mic hasn't been working. Is it working now?
It is working now, yay. Did it cut out again? Or are you just not talking? Oh, you're trying to talk and I saw your lips move, but I didn't hear anything. Do you want to type it? What's the cosine of 30? Here, we'll look at the chat. That's weird that it worked and then it quit working. That's weird. Square root of 3 over 2, perfect. Okay, so the cosine of 30 is square root of 3 divided by 2, Okay. So the question is this going to be positive square root of 3 over 2 or negative? And let's see here. Come here. Negative. Very good. Well done. Okay. Thank you. And I wish your microphone kept working. That's weird. Okay. So cosine of 210 is negative square root of 3 over 2. Okay. So now let's move on to the next person. The tangent of 30 degrees equals, okay, Texas, it must be your turn.
The tangent of 30 degrees would be the square root of 3 over 3. Right?
Square root of 3 over 3. Okay. So if we do the tangent of 210, the question is it positive square root of 3 over 3 or is it negative?
Positive.
Positive because
It's in quadrant 3.
Quadrant 3 and T tangent is always positive in quadrant 3.
Right.
Okay. All right. Are we getting this down? Is this pretty good?
Yeah.
Are you guys feeling pretty smart today? Smarter than when you walked into class? All right. Or I guess you didn't walk into class. You're probably all sat down in class. All right. Go back to here. All right. Let's do another one. Well, this time we're going to do the cosine of 405 degrees. Okay. Here, we'll draw a new thing. Whatever. It's going to have to be good. Okay, so the first question is, if we're doing the cosine of 405 degrees, okay, where are we? Which quadrant are we in? And, oh, okay, thanks, Tayton. Sorry about that. Hopefully your microphone will work better. Okay, let's see here. It must be, whose turn is it now? We'll start at the top. Brian Larson, which quadrant are we in with the cosine of 405 degrees?
Sorry. So it'd be 1 full rotation and then plus.
Yeah. So this is, so 1 full rotation is 360 degrees, right?
Yeah. Plus the difference of 360 and 405, which is
405 minus 360 would be
45.
45. So really all we care about is a cosine of a 45 degree angle, right?
Yeah.
Okay. That will be our reference angle because we've gone all the way around and now we're at 45. So that's nice. So we're really just looking at a 45 degree angle. So, and the nice thing about this is what? What do we know about all of my functions in quadrant 1?
They're all positive.
All positive. Okay, so do you remember what the cosine of 45 degrees is in quadrant 1?
The square root of 2 over 2?
Oh, that was a question.
Yeah, that's it.
That's it. Okay, very good. All right, well done. Okay, squared 2 over 2, and it's positive because everything's positive. Okay, let's go back to my notes here. Tangent of 5 pi thirds. We'll do that one in blue this time. So tangent of 5 pi divided by 3. Now that one's going to be a little harder to figure out, right? Let's think about that. So which quadrant is that in? Okay. And let's think about how we can figure that out. So quadrant. Okay, so we just picked quadrant. We'll put a question mark there. Okay. So Cameron Daly.
Yeah.
This is going to be a hard one, isn't it? Because we don't think in terms of pi very well. But you do remember, hopefully, don't you? What is pi thirds in degrees?
Pi thirds is 60.
60. Okay. So essentially, so this is 5 times 60, right?
Yeah.
Okay. So 5 pi thirds would be the equivalent to what in degrees?
300 degrees.
Tangent of 300 degrees. Okay. Okay. So where is 300 degrees in which quadrant is it in?
Fourth.
It's in quadrant 4. Okay. So we're at, okay. So essentially, so 300 degrees. So essentially what we've got here is, what's your reference angle here that I just drew?
That would be 60.
That would be your 60-degree angle. Okay. So we're in this, so this is a 60-degree angle. Okay. Okay, so we're in quadrant 4, 60-degree angle. Do you remember what the tangent of 60 degrees is?
Tangent of 60 square root of 3.
Very good, except that was a question.
Yeah.
I just like giving you guys a hard time. If I tease you too much, let me know and I'll stop. Okay, so it's a 60-degree angle. We know that it's the square root of 3. Now the question is it positive? Oh, I didn't mean to stop that off. Is it positive or negative?
Fourth quadrant. It'd be negative.
So that's correct. So equals the negative square root of 3. I'm impressed that you guys are have that memorized as good as you do, because I know that's but I'm telling you what, that's going to be that will save your bacon on the test. Okay. So yes, all right. So we've got that all there. So I reprinted.
I have a quick question.
Okay.
So on that last one with the tangent, why is it that we looked at the 60-degree angle between that portion, but like with like the cosine of 405, we were looking at the part, let me see if I can phrase it, like the part below the angle, like closer to, if that makes sense. I don't know.
Yeah, so it is a good question. We're always measuring it from the x-axis.
Oh, okay.
Always, yeah. So and so that you're using the correct terminology, remember, this is your initial side, and then when we rotate all the way around here, this is your terminal side. Okay. So whenever we're measuring it, we're always measuring it from the x-axis. And then that will make our lives easier. So yeah, so you'll want to remember those terms, initial side and terminal side as well. And so we'll refer to this in both cases. This blue angle is the reference angle, and even this red angle will be the reference angle as well. And this even over here, reference angle. Okay. All right. So yeah. So once again, I need to move that. So if you haven't got this table memorized yet, really, the most important things you need are sine, cosine, tangent. You really need to memorize this because you can figure all this out because it's just reciprocals. So once again, just as another quick reminder, when you're going sines, it's 1, 2, 3. It's a square root of 1, 2, 3, 4 over 2. And in cosine, it's just backwards, square root of 4, 3, 2, 1. And then, all right, so there's one more thing. Looks like we're going to get done a little bit early today. So let me make this a little bit bigger. So remember, theta prime equals theta if you're in quadrant 1. So if your theta is between 0 and 90 degrees, if your reference angle is between 0 and 90 degrees, then your theta prime equals your theta, and you're in quadrant 1. If your reference angle is between 90 and 180 degrees, then your theta prime is going to be 180 minus your theta. Okay, so this is your reference angle. If your theta is between 180 and 270, then your theta prime is going to be your theta minus 180 degrees. I don't know if this is all that helpful. I think I explained it better the first time, but this is in the book. So, and then if your angle theta is in between 270 and 360, then it's just going to be 360 minus your theta. So if you want to memorize that, I think that's actually harder to do, but I think the way we did it was really good. So remember, the reference angle theorem is hugely helpful. And also remember, all students take calculus. That will help you remember which is positive and which is negative. So those are hugely important. Also, just kind of as a quick review, these 3 things are also going to be very, very, very helpful to memorize. And so, yeah. So yeah, if you don't have this memorized, memorize it today, because you really need to know that. I don't really want to start on the next section today. Do you guys have any questions for me?
No, pretty understandable.
Okay. All right, so this is good. I haven't made copies of, and we didn't lose power today, so that's good. So I will make copies of the homework. I'll post that shortly. I am curious though. Here, let me do a quick poll. How many of you have the book? I'll put this in the chat. Just put a thumbs up if you have the book and you don't have the book. A thumbs up if you don't have the book. I'm just curious. How many people do we even have here? I wonder, let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got only 12 people here. There's 20 in the class. Where is everybody? Go back to the chat here. Oh, except for you're supposed to put the thumbs up on, because Samantha, I don't know which one you're thumbs upping me. So click on the have book. You have the book?
I didn't realize. So I thumbs up your comment, and yeah. So I do have it.
Okay. So Texas, you have the book too?
I have the book.
Nicole, okay. So Kobe does
well, it's
not.
an ebook, but it's still the book.
Yeah, whatever. Yeah, that's fine. Okay, so it looks like about half the class does and half the class doesn't. So, okay. So anyway, I was just curious about that. All right. Well, I will make copies. I'll make your quiz. Yours should ship today. Oh, Cameron Ravert, are you gonna get it? Did they say when? Is it free 2-day shipping? You'll have it by Saturday?
I meant like it'll be at my house today, not like it should.
Oh, it'll be at
it's
your
already
house.
been shipped, yeah.
Okay, cool.
So
all right.
I'll get it today.
Cool. All right. So hopefully everybody, I know it'll be a lot more helpful when you actually have a book. So you have the ebook already. Perfect. Okay. Any other questions before I let you guys go?
No.
Okay. All right. Well, you get 10 minutes early. I will get my notes up and the homework up as soon as I can, and another quiz due tomorrow. So we'll let you guys go. Thanks again.
Yep.
Thank you.
Oh, and also for you guys, if you guys want to do another